We are going to train a linear regression model in Python. We are using scikit-learn. So if you um, if you want to find example code how to use the library, scikit-learn provides really nice documents. So if you click here, you will see this page. So you can see how these methods, what sort of parameters are used in these methods. And if you scroll down, actually there's a example code. So you can import it by this. And this is example data, so you can ignore it. But it shows how you declare the model and fit the model. All the models in scikit-learn use the same method, and this fit method is used for every machine learning algorithm implemented in scikit-learn to train the model. So this simple method with the data set, which is a descriptor in our case, and this is a label, in our case PLC50 value, then this just one line finds good weights for the model, and you can check the accuracy of the model. And also you can print the weight of the model. So you can find it with the here the model is trained in this variable reg, and reg.coefficient, short for coefficient, coef on the bar, gives you weight of the model, and intercept give you the bias of the model. So if you know these values, you can implement the model even in the Excel file, and also you can make a prediction. So let's go to the code. So I'm working with this data set. Here in this tab, I have this data set. So here's the feature values and the label experimental value, and this is a prediction value, but not by it's given by author of the paper. So you can compare the accuracy of the model with this value. But anyway, we don't need to consider this column at the moment, but we'll focus on here. So if you read the file data frame, I skip the first row and ignore the 27 rows from the bottom. So this is my training set and my test set. No, it's not my test set. This is a training set, and I specify the name of the column to select these values alone. And I do that because when I train the model, I don't need this ID, because this is not really a descriptor or informative data for the model. These from MV to ALOP are the descriptors I want to use. So I need to subset the data frame. And how do you subset the data frame? You can do that by using the column names. So you specify these data set here, and I named it as a X-train. I can do the same with this. I define call name in this variable. I put this value, which means df underbar train.columns return all the name of columns, and I select from 1 to 7. So index starts from 0, 0, 1, 2, 3, 4, 5, 6, 7. Doesn't select up to 7, but it's select up to 6 if you give in this index. So 1 colon 7 means from 1 to seventh element, which is 6. So this is how I can also, without typing the column name, I can give a column name using this. The column name is given to the data frame, and this training set is selected. So I named it X train because this will be the X variable of the model. And then I select the Y train, which is the endpoint the model should predict. So this is a simple way of subsetting the dataset. We will learn how to calculate descriptor later, but here I'm focusing on how to subset the descriptor from the entire data frame. And then training the model is much more simple. So I just call the linear regression from scikit-learn. I define it on the reg variable and then use fit. And I give this to data frame. Then it trained the model. So it uses X train, descriptor values in X train, and predict endpoints in Y train here. So this is how I train the model. Very simple. And this reg.score is a prediction accuracy. And prediction accuracy here, this score is calculating R square, R superscript 2, and we call it R square. And this value is good if it's higher, and the maximum value is 1. And it's decreased from the 1. So if the model gives high R square, then the model is very accurate. So I check the model's accuracy on training set, and then I check the model's coefficient, which is these values, these 1, 2, 3, 4, 5, 6, and the bias. So by these two lines, I train the linear regression model, and I can make a prediction if I have a descriptor value in this way. But these weight values are found using the training set. So it's obvious that the model can make a good prediction on the training set. So that's why we always need a test set, which is not used in training process, but it has a similar distribution with the training set. So model should also make a good prediction on the test set. So that's the concept of the test set. So if you see this Excel file, there's a training set and then test set. So to select the test set alone, I should skip the 72 rows from the above, which means, so from here and up to here. These are actually in total 72 rows. And I only skip the 72 rows because first row is always ignored. Thinking it as if it's a column name. So I just need to skip the remaining rows to specifically select the test set defined here. Okay. So I have the test set and I select the X test in the same way. And also Y test. And then I can make a score, which is a 0.86, higher than the training score, which is unusual, I think. But anyway, not that bad. So this is how I can train the model and confirm the prediction accuracy of the model.